guys? Welcome to my channel. I'm Genie Coder. If you guys are new here, I pretty much do legal style questions and I explain things in the simplest way possible. Today we have an amazing problem for you guys, man. We're gonna be going over how to implement a try, guys. So let's read the prompt statement, right? So it says a try, right? Or prefix tree is a data structure used to efficiently store and retrieve keys in a data set of strings, right? So he says there are various applications of the data structure, right? Such as autocomplete and spell checker, right? So this is a good kind of summary of, you know, telling us about what the try is about and what kind of application that we have for, using tries, right? Autocomplete is a good one and spell checker is a good one, right? So as we do the problem, you'll see how they're also efficient at helping us guys in storing words in a dictionary, right? How helpful they are for solving problems that kind of need that, what I'm saying, that data structure, right? So pretty much this they're telling us all the stuff that we need to fill out, right? So there's going to be the try constructor, right? And there's going to be this word, right? There's going to be this insert function that we're going to enter the word into, right? There's going to be this search function that's going to pretty much search for a word in the try, right? And yeah, and it starts with and pretty much letting us know if there's a word that exists, right, that starts with that given prefix, guys. So very, very important, right? So yeah, so they told us that, they told us exactly what it is, right? A trie is a prefix tree, right? It's a tree, right? You know what I'm saying? So you know that, it's gonna pretty much represent a tree pretty much, right? It's gonna be a node. They're gonna have children nodes, right, that they're pointing to, just like a binary tree, just like an n tree that we've done so far, guys, on this channel. So the same kind of concept applies here. It's a tree, right? So just this tree, helps us in our story, work and stuff like that, right? So guys, yeah, so this is the example that's given to us, right? We're given a try, right? You know what I'm saying? It gets initialized, then we insert apple into the try, right? And then, and then we search for the word apple, right? And if it exists, right? It says if it exists, we return true, guys, right? We return true if it exists, right? Apple exists indeed, so we're good. And then we search for the word app, right? App is not in there, right? Even though there's a prefix app in there, right? Um, the pre app is a prefix for Apple, right? But it's not a word, right? We didn't add it in there. We didn't add that word in there. We added Apple, right? So you can kind of see how we're gonna need a way to differentiate between uh, what words we've added and what words are prefix. And what I'm saying, yeah, we're gonna go over that, guys. Don't worry. And then when we do starts with, right? Indeed, it returns, right? It returns true, right? Because guys, there's a word in there, right? So that we added apple that starts with the word with the prefix app, right? So it returns true, right? It's good, right? And then we insert app, and then once we search for app now, then we're able to say, all right, cool, we have app as a word because we added that word in their app, right? In the try. So we could say after searching the try, we found the word app in there, right? So we could do that, guys. So this is a very, very good problem. I like it a lot. So you can see, so now our job now is to implement those functions that we have here, guys. By implementing those functions, we're gonna have this all those functionalities that they're asking for, guys. So I'm gonna take you guys to my drawing board so you guys can see exactly what kind of stuff that we're gonna need to do, guys, right? So yeah, guys, we'll be going over a couple, a couple of examples real quick, right? So pretty much, guys, we know what a trie is, guys. A trie is a tree, guys, that you read from the statement, right? You know what I'm saying? And it's similar to like a binary tree and n tree. So they're trees, right? All those things are trees, right? So this mostly resembles an n tree, guys. So we've done a problem in that already. So something should pop up. So you guys could go there and maybe, kind of go through it so you kind of see how similar they are, guys. So pretty much the trie, right, is going to be consisted of, trinodes, right? That's going to make up the tree, what I'm saying. And the data, how the data is going to look like, guys, pretty much every node is going to pretty much have some kind of data, right? A character, I'm saying. The character for that particular node, right? Pretty much think of it as like the value of that node, right? Just like, binary tree, normally, you have an inval or whatever data we have in there, right? So this is holding a character, right? At for that node, right? And also, we're going to store pointers to children, right? Because we need pointers to all of those children. Right? That's how we traverse. We're going to be able to traverse the tree and things like that. So we need those pointers to our to child nodes, right? So um, there's going to be for this problem, it's going to be 26 children at max, right? Because guys, we're storing the characters from A through Z, right? Which is 26 characters in the English alphabet, right? So now we're good on that, right? So this is 26, and this is an additional one, right? Which is called end, right? Pretty much to let us know if a character ends at this particular spot, guys. This is that job of this pretty much property to let us know if there's a word that ends at this character. So we'll go through a couple more examples so you could fully see what's really going on, guys. So pretty much, guys. So pretty much we need a trie, right? Always gonna have a root, guys. So we need a root, right? So the root, guys, can be any character you want, right? So pretty much I'm choosing a backslash, right? That doesn't matter. I'm saying slash, right? Just to represent the root, guys. So because that's gonna give us access, guys, to the trie, guys, by having access to the root, right? So this is the root, right? So very, very important. Make sure you guys are following, right? So now from the root, right, we're gonna pretty much traverse the trie. So right now, we initialize the root trie, right? So now we're gonna be inserting into the trie, right? So it's gonna be relatively simple. So we need to insert the word apple, right? So we're gonna insert into the trie character by character, right? So pretty much we try to add the first one, right? So we see the root, right? You know what I'm saying? The root, does it have any a right as on the children, like child node, right? Nope, there is nothing. It's not pointing to any node right now because it's a brand new trie, right? So it's empty, right? So we can easily add, guys. We're going to be adding we're going to add the character, right, which is a, right? A, and then the end, right? I'm saying the end one is going to be 0, right? It's going to be false, right? 0. So I'll put 0 for simplicity, right? So it's 0 initially because it's 0 right now because that's not an end word, right? So that's the default value, right? So I'm not going to change it. I'm going to leave it as such, right? And then now we need to add the other character, which is p, right? So we're going to simply add p, guys, which is very, very important, right? Add p, right? So p is the next character, and we add pretty much that's 0 as well, right? It doesn't end there. Okay, so we go on, we add the next one, we do the same thing. There's the other character is APP, right? So we need to add a P again, right? What I'm saying. So we add it into the trie like that, guys. No, every time we add a character, we move on to the next one, right? So now we're gonna end is 0 right now, right? So once we get every time we add a character, right, we go on to the next one, boom, and then we add the next one, boom, right? And then at this level, we need to so now we'll be pointing to here, right? Once in the code, I'm saying when we're entering the elements, right? So we're pointing here, right? So now with the next character, right? Since this just got created, right? So it's not gonna be pointing to anything yet, right? So all the 26 child pointers that it has, right, are pointing to null at the moment, right? They're all, I'm saying. And yeah, so the next character is L, right? So we're gonna add L to the trie, guys, right? Trie. So we add an L in there, right? And then it's gonna be 0 as well. And then the last character that we're gonna add, right? So now we're pointing here, right? The next character is gonna be a E, right? But this time the N will be 1 to signify true. That this is the end, right? There was a word that ended at this particular node, right? Which is very, very, very important, guys. So that's how we insert it into the actual trie, right? So now we're gonna search for the thing, right? So now same thing again, right? We're gonna get reference to the root, right? So once we get a reference, we could easily loop through, guys, and traverse the trie, guys, right? So pretty much what we would do, we would search for the word apple, right? Searching for apple. We pretty much get a reference to the root, and then we go to A, right? Does A exist, right? A does exist, right? So we're good. All right. So we go here again, right? And does P exist, right? P exists, yeah. So we add P right now, right? We're pointing at P right now, right? So now P, right? Is gonna ask, do I have reference to a P, right? Which is this P, right? Yeah, I do have reference to a P. So I go here. I'm good. All right. So all right. So I'm here. We're here now, right? And then P it's gonna see if it has reference to an L, right? Because that's what it's looking for. So we have reference to L, so we'll put it here. And then L is gonna check, do we have reference to an E, right? Because that's the next character, right? That's in the word, right? I'm searching this. This is how we're searching, guys, right? We search, yeah, I have reference to an E, so boom. So now I've processed all the words, right? So now I check, right? Um, is that word, right? Is that last node that I'm on right now, right? Is it, does the and property, is it true, right? To signify that there was a word that we added in the try, right? That ended at that particular node when we added it, right? So yes, indeed, it is true, guys. As you can see, right? It is true. So we're going to return true that the word does indeed exist, right? So that's why we return true here, guys. So and then right here, right, search for the word app, right? The same thing happens again, right? So I'm just gonna clear those out real quick. So same thing applies, guys. So we get right. So we're searching for the word app, right? We traverse, right? We get reference to the root, right? There's an A, yeah. So we go keep traversing. There's a B, there's a P, right? We keep traversing. Or I have reference to P. There's a P, right? Boom. Then I process all the words, right? And I get out, and I see is there a word that we added in the try, right? That that ends at this particular node, right? Nope. You can see that the end property is false, right? So that's why we return false, because we didn't add any word in the try yet, right? As of yet, right? Um that ended with this particular app, right? You know what I'm saying? There's a word that has a prefix app as I'm saying it's a prefix, right? But it doesn't. I'm saying that's why when we do the next operation, it starts with, right? It starts with the word app, right? We do the same thing. We traverse. We go here, go down. We have A in there. I have P. I have a P, right? And then we return, right? So if we're able to traverse the whole input string that's given to us, right? And we end up having those sequence of nodes, right? Just like that, right? App, right? So I have reference to A has reference to P, P has reference to another P, right? If I'm able to do that, right? If I'm able to search for a prefix, right? Able to traverse the whole tree, and I'll return true, right? That's why they return true here, right? Yeah, guys. So if it's not in there, if there's no word that starts with a given prefix, we wouldn't be able to traverse the try. We will return false as soon as we see that we don't have reference to that node, right? I'm saying so we return false. So yeah, so true. So we answered the word app, right? So the same thing, we traverse A, we go to P again, right? And then right now the current P is 0, right? There's no word that any of that word yet, right? So we can easily switch it to a 1 now to, so now the next time we search the try, right, for the word app, right, we're gonna end up finding it now. It's gonna be true, right? You see, initially it was false when we searched it before, right? So now it's gonna be true, guys. So this is the beauty of it, guys. You know what I'm saying? And let's say we were looking for, I'm saying, like the word like basket, right? It would not be included in the try, guys. We will return false, what I'm saying. So you see, when we're adding words, right? You know, let's say we're adding see, we added app, right? You see, we didn't create a new node for the word app, right? We didn't do that, right? There's no need for that since we already have uh, a word that already starts with the same prefix as the word app, right? So we don't need to add additional stuff, right? We could just keep doing that, guys. Use the same path, right? And just once we get to our end node, right? We just change whatever property it had before. We change it with this new property to say, true. There's a word that's been added at that particular spot, guys. So there's a lot of great stuff you can do with try, guys. So this is just one of the simple stuff that we're doing, guys. So what is the next thing that we're going to do now, guys? Let's go ahead and implement the code. Hopefully you guys will follow the thought process and how we're going to go up after it. So let's quickly try to implement everything, right? So yeah, so what we're going to have here, guys, is going to be very intuitive, guys. So right now we're going to have a root, right? Remember we said the root, guys, is going to pretty much help us at having access to the structure, right? So pretty much this is how we're going to initialize. So now we need to implement like some kind of node, I'm saying, structure to let us know, like, the type, right? So pretty much, every node, right, is gonna have, guys, a constructor, right? So we need a couple of things, right? Char data, right? Just the same model that we've already talked about before. So data, we said that we're gonna store the children pointers, right? Yeah. So we would in constructor we're gonna get a char data, right? And then we're gonna do this that data, right? Let's go to data, right? And also once we add it, right, in constructor, right, we just gonna increment. We just gonna create a an array, right? New node array, right? I'm saying of what, guys? Of I'm saying node type, right? Same type, because you know what I'm saying. And it's gonna be of size 26, guys, to store all the characters in the English alphabet, right, from A through Z, guys. So very, very important, right? Lowercase, right? So once we do that, we're in good shape. So now we're gonna insert a word into the trie, right? How are we gonna do that, guys? You know, we're pretty much gonna traverse the trie, guys. So pretty much we get reference to the root, guys. Very, very important, right? Get reference to the root. Just like I was doing in the walkthrough, guys, right? We get reference to the root. And after we do that, right, we simply, guys, right, do int easy way to look through the word, right? So word that length, right? I plus plus, right? All right, just make sure it's clear for you guys, right? So we're gonna add every word one by one, right? So pretty much, guys, we need to index the words, the character that we're aiming for. Right? We need to make sure we index to the right thing, right? So we know that the character A, right, the children of whatever I'm saying is gonna be at their first index, right? And then B is gonna be at the second index, and then C is gonna be at the third index, right? Just like that. This is how we're gonna index the words, right? So pretty much the way it's gonna happen, right? We're gonna need to do word that char at, right? I, right? So this is the current word that we're on right now, right? Gonna do minus A, right? To get the ASCII value. So pretty much we're just comparing ASCII values, right? And then that's how we're gonna easily be able to index. So pretty much for this character, I say this character was A, right? It'll be A minus A, right? Which is I think 97 or something like that. It'll be 97 minus 9, so it'll be 0 now, right? So the index 0, right? This is the children at index 0. This is the one that I want to, you know, that I'm referencing to, right? So pretty much we're going to do a check, guys. That's very important, right? So pretty much what we're going to do, right? So remember that cur, right? So we got reference to the root, right? So now cur is going to check, right? Cur that children, right? Because remember we're storing the pointers in an array, right? So that children, right? The index of that, right? The node, the character, do I have, is it null, right? If it's null, right? I'm inserting, guys. If it's null, what I'm gonna do, guys, is gonna be very intuitive. We're gonna do create that children index, right? We're gonna create a new node for that child, right? If I don't have a reference to it yet. Remember when I was adding, right? When I was adding a new node, this is exactly what's going on right there. Right? I created a new node so I could point to it. So now I have a reference to that node, guys. Which is very, very, very important, guys. And you guys make sure you guys understand, right? So now, what's the character I'm gonna put in there? I mean, it's gonna be the word that you're at I, right? This is the character that I'm pointing at, right? So this is the character that I want to point at indeed, right? So now after we do that, right? So now I created a new thing for it, right? So I can just go on to that character, right? This is exactly what we're doing, guys. So I'm just make sure that I go back. Actually, see, this is this case right now. We didn't have A in there, right? So we added A, right? After we add A, we go to A so we could point to A. So now A in the next iteration, right, is going to check, does it have a P, right? If it doesn't have a P, it creates a node for P, right? And then goes on to the next one. It keeps doing that over and over until we reach the end, guys, right? Just make sure you guys are following through it and make sure everything's clear to you guys, right? So we keep doing that, you know, after we process all the characters in the trie, right? And I mean all the characters in the word, right? In the string, right? The last word, guys, right? The last character, I mean, right? So I don't think I added it, right? So pretty much we need to make sure that we add that property, right? So it's gonna be false by default. So yeah. So now the last character, right, that we add in the trie, right, is gonna be set to true, guys, right? So now when we search for it, guys, so it's pretty much gonna be the same thing that we have here, guys. Just a slight modification to the what we have. So I could copy literally the whole thing, and then we're gonna paste it in there. And pretty much gonna be the same thing. We know how to look through words, right? We're pretty comfortable with that. Every time we need to get a reference to the root so we could start each reversal, right? So now what are we gonna return, guys? The same thing, guys, right? Pretty much now we're not setting it now. We're checking does the last character that we've so pretty much see we traverse the stuff character by character, guys. So yeah, so now this case, right? No, remember when we were adding, right? When we check if we don't have X reference to it, that node yet, right? We would return, um, we would create a new one for it, right? But for this one, guys, we wouldn't do that, right? What we would do, we'll return all false, guys, to say, yo, we don't have that in there, unfortunately, right? So we gonna this is, yeah. So yeah, so this will be the case. Let's say, while we're checking for the word basket, right? And word basket, right? There's no, so now basket, right? So just make sure we're looking for the word basket, right? Right. And yeah, so root doesn't have a B, right? It does not have a B, guy. That does not exist in the trie that we've created so far, right? So we will return false because that pointer would be null, right? Because we didn't create a node for it yet, so it would be null, guys. This will be the case, and we'll automatically return false, guys, right? And this cur.end that we have here, right, was the case when we didn't add the word app yet, right? But the app was a prefix, right? But it wasn't a word yet in there, right? So because of that, it was zero, right? It was false at that particular at the earlier case, right? And we ended up returning false because we didn't add a word yet that started with that, right? So this is what's going on here, guys. So yeah, you can see how easy it is to traverse the try, guys. You know, easy it is to um, traverse, guys. So we're gonna do the exact same thing again, right? For the um, um, but this starts with function, right? So this one's gonna be a little bit different, a little bit of modification, right? But it's the same thing, guys, almost the same thing. So uh, if it's null, right, obviously we return false, guys, right? And then same thing, I'm saying. So, and then if we end up processing, like looping through all the characters and the prefix, right? Then we could safely say that yeah, there's a word in there that starts with that given prefix, right? Because if there wasn't a word that didn't start with that prefix, right, we would have hit that condition, right? Create that children index is equal to null, right? Because I wouldn't be pointing to that child, right? So I'm like, yo, I don't have that in there, so I will return false, guys. So it looks like we got everything in place. I don't know, might be a little bit of syntax error. So let me see what we have here. It says that okay. Oh yeah, prefix. Make sure that I add prefix, guys. Very, very important. I'm gonna press run code. Oh yeah, make sure that you change every reference, guys. So okay, it looks like everything's fine now. All right, seems like we passed down the small test case. Let's see if we pass all the test cases. Awesome, guys. We're able to pass all the test cases, guys. So this was quite a long one, guys. So yeah, yeah, I want to thank you guys for watching this video, guys. And if you guys found value, make sure to give me a like, guys. I would appreciate that a lot. If you're new here, make sure to subscribe to the channel, guys. We're gonna be doing a lot of videos just like this one. So go ahead and subscribe, and now let's get into it, okay? So I want to thank you guys for watching, and I'll see you guys in the next.